It's nanotech. You like it?
Does it come in black? Hey guys, it's Michael from the GSC Sim Team, and as Avengers Endgame is right around the corner, today I thought we'd talk a little bit about Iron Man's previous suit, the Mark 50, and how he's using FEA, finite element analysis, and topology optimization tools to find the material he needs in order to create his different weapons and defenses. To demonstrate this, I'm going to run a quick study using TOSCA combined with Abaqus's FEA solver, which are both products from Dassault Systemes' Simulia line of software. So in that last clip, we see Tony holding up one arm to defend himself, but his suit does have a finite limit of material it can pull from. So now he needs to pull from what's available. By incorporating FEA solvers and TOSCA into into the programming of his suit, he's able to calculate where and how the material is pulled without compromising any immediate structural requirements. So total sidebar, but I was wondering how Tony was able to do this with this technology, and I stumbled across a Dassault and Stark Industries partner agreement back in 2012. But we'll get back to it here. So the first thing is you have to start with FEA. I'm not going to get into the particulars of how the FEA model was set up, but what you can see here are Justin von Mies's stress results of an analysis that was conducted. And what we have is a force that was applied to the right arm of our humanoid shape, and you see that load that's traveling through the shape. So you have significant load traveling through the back leg, where the stress spikes are hitting behind the back left knee and in the right ankle area. And there's also stress concentration in the front right elbow, which is taking the initial force itself. Now the core of the body, the off arm, the head, even the thigh on the right leg, they're not taking that much load, or at least not much on the stress concentration. So now once we've run our initial FEA, now the next task is to start up a TOSCA. Once you've opened your TOSCA GUI, you can select TOSCA Wizard and select which type of optimization study you want. In this case, we're just doing topology optimization. And then you need to find your input deck from your Abaqus file. So this is going to have the analysis job that you just ran. And you would need to specify which elements you plan to remove parts or material from. Then you'll specify what sort of analysis you want to do. So are you going to increase your stiffness, reduce your volume? To how much will you reduce your volume? And then you can define any frozen areas if you haven't already specified it in your input file. And you can activate any casting restraints. So for us, we're removing material only from the X direction, going up or down. So it can remove from both directions, but it won't just create random voids. And then you save your model and you start your optimization study. And it's pretty straightforward. So from here, it'll now just run iterations going back and forth between the Abaqus solver and your results until it finally converges or hits the volume or stiffness criteria that you were looking to meet. Okay, I'm just going to speed through this analysis. Real time, it took about 15 minutes to solve, which is pretty quick. I've run some jobs that are taking about 6 hours, some overnight, some can be longer, but it really just depends on what you're doing. Now, but what I want you to see here is your output results that you can get from TOSCA. You're going to get a video of the iterations, and you're also going to get your smoothed over last iteration picture. And then you can also get your CAD geometry from here as well to import into your SolidWorks for a new part, for kind of finalizing that new part. Now, if you're looking at, for our particular study, you see material from the head, the top torso, and even in the foot area were removed. Now there are elements also throughout the core itself that were stiffened up a little bit, and areas that were kind of removed along the way. But the majority of things that were moved were right in that shoulder area and kind of right around in the foot area. because they were considered to not have any effects for holding that load. So if you look, when we turn his arm around, you can see material was also removed from the top of the right arm and in part of the foot area. And so that's how, in Tony Stark's case, his programming was able to determine, okay, this is where we can get the material in order to create that sword. So this is the type of study that you can do on existing parts. So if you're trying to find out what's the least amount of material you can use to create the optimal result within a certain safety factor or whatever your safety factor guidelines are, this is a great tool that's used for that. Because traditionally you would have to run an FEA job and then look at it and then try to make some sort of judgment about where you can stiffen a material part or where you can alter the geometry of a part. But by using a tool like this, you're letting the software take all of your own pre ideas of how to design a part to affect your end result. So what you're basically doing is letting the software remove elements from your mesh that are not critical, and it does not care about what is maybe considered, oh, that's a good looking design. It's just doing what's best for your particular analysis job. So this is TOSCA. Thanks everybody for tuning in. That finishes up this video. I'll be doing another one in a couple of weeks on Abaqus and nonlinear dynamic analysis. If you have any questions, feel free to shoot me an email. All right, see you out there.